is in the exponent. Now, this standard form here, a times b to the x power, the a and b are not variables. They're constants that will change for each function. For example, here the a is 3 and the b is 4. Right? The x is still a variable. So you will have a variable in the exponent. That's what makes it an exponential function. The a and b are constants. They're real numbers. The a does not equal 0 because what would happen if a equals 0? Do you see it divide by 0 there? What would happen if a is 0? The whole thing would be 0, right? It would not be exponential anymore because the whole thing's 0. The b is defined as being greater than 0, but it's never equal to 1. Why? What would happen if b equals 1? Yeah, that would make this term just 1 all the time. So it actually wouldn't be exponential anymore anyways. Okay. Now, the one thing that we do that is a fairly common mistake that you have to not do it is it is a very severe error that if I look at this problem right here, make sure I'm on, right, you cannot multiply those and say 12. Why can't you multiply those? Say again? Well, say, yeah, obviously there's an exponent. Why can't I just say that's 12 to the x? Well, because this 3, go ahead, Ariana. Because 3 is not raised to the x power. If 3 was raised to the x power, then you could say, in parentheses, 3 times 4, 12 to the x. But because the 3 is not raised to the x power, you can't multiply them. So don't do that, right? If you start out on the problem by saying 12, then you just lost all the points. There's not much you can say about it after that point. So never multiply that, right? This 3 is not raised to the x. Only the 4 is. Right, that's exponential.